Thanks everyone. So I would like to start this session by outlining what to expect from it. Due to potential time constraints, I would like to go ahead and showcase an already bootstrapped AlgoKit template, but to outline how this was actually generated, you can expect this to be just a slightly tweaked and modified Algorand Python template that you get when you initially use AlgoKit CLI and execute the init command. But the goal is actually just to give you sort of look and feel of typical ebbs and flows that you would get when developing on AlgoKit CLI, and hopefully showcase some features that may be a little bit obscure and some of the features that I'd say would demystify a little bit the term AlgoKit itself. And the goal here is really just to showcase the fact that it's not just a CLI tool. It's a bundle of at least 30 to 40 different features that gets you covered, starting from building, deploying, and testing your smart contracts. So what we're going to do is write a very simple proof of attendance smart contract. We're going to showcase a few scenarios of how you can identify and fix bugs at the level of compilation using Puya compiler, at the runtime, so after deploying to AVM in local net and trying to execute something, we'll see how you could potentially use the Teal debugger extension and actually have line-by-line debugging of Teal using the simulated traces. And at the end of it, we'll essentially showcase the final deploy command. We'll deploy the smart contract on chain, and we'll have a little, I guess, raffle. So if people have their Para or DeFi wallets ready on mainnet, at the end of this presentation, there's going to be a little QR that you can scan, and the first 3 people who are going to scan this thing are going to get access to a free Subtopia subscription, which is basically a platform that allows you to monetize your decentralized applications. And so with that, I would like to start with a showcase of what we have right now. For those who want to interactively follow me, feel free to do so, but I would just like to outline that for the sake of time, I won't be able to individually answer you during the talk, but I can help you out after. So if you have a laptop with you, you can follow. But other than that, let me start by showcasing what's the content of the template. I'll give a few seconds for whoever wants to get the repository access. You just need to scan this QR code, and that's the path to the repository. But we can. Okay, I see some people actually scanning. So that's assuming if you have your laptop with you. So let's continue. Basically, the out-of-the-box content of that repository is a default Algorand Python template. If we look into what the Visual Studio Code is showing to us, every single AlgoKit template, starting from AlgoKit v2, which was this big release we had roughly 3 months ago, now have a native support for monorepos. So essentially, it allows you to compile different kinds of programs together, because the app doesn't necessarily only constitute of a front end, right? It has a smart contract component. The smart contracts themselves can be written in multiple languages as well. And so there was a clear need for us to also give additional level of flexibility for AlgoKit template. So by default, there's a base template at the root of the project, and if you go to algokit.toml file, you can see that the type of this project says it's a workspace. So basically, it means that this is the root of the workspace that can host multiple standalone projects. In this case, we have only one standalone project, and that's a Python project. So you can see that it also generates the code workspace for us. So you can conveniently have a monorepo expanded in your Visual Studio Code and work on front end. For example, if you want to quickly iterate essentially and see the changes that you have in the deploy contracts, and you can also do the changes in the Python code as well. So if you look into the algokit.toml file, think of it as something like package.json, right? So in case of an algokit.toml file for standalone projects, there's a little bit more information and configuration available there out of the box. We could see that the type of this particular project says contract, so it's just a generic category to classify kinds of projects that would solely focus on smart contracts. We could see the name, we could see the folder where it's going to drop our artifacts. In this case, this is our ARC32 specifications, our Teal code. And then there is some additional configuration, but I would just like to highlight one extra thing, which is project run. So the same way as you can define custom runnable commands, such as npm run, for example, that masks different commands that you would like to execute. In order to manage this properly as a monorepo, potentially, you can define a set of custom commands to execute and use AlgoKit as the main interface to trigger those commands. So when we go to the root, in this particular case, I can just create a new session here, and if you do AlgoKit project run, you could see that it automatically parses the content of all commands that are available under the sub-projects. And we have things like audit, audit teal. Audit teal comes in with the production preset. There's two kinds of presets available, starter and production, which we think is a good starting sensible defaults for developing these projects. Audit teal uses a third-party integration, Tealer, which is a very flexible way to essentially customize and do some additional checks on your raw teal code. We have the build command. Build command is going to use the Puya compiler in this case. Why? Because we have a Python project. And then we have some additional commands for linting and testing. So this allows you to easily encapsulate all of these commands in your CI/CD, which you also get for free out of the box as part of the template. So you can see some example of a ready-made starter CI/CD that you get that will deploy these contracts to testnet for you. Obviously, there's a lot of additional precautions for mainnet. We don't recommend you to directly deploy from stored mnemonics there. This is completely unsafe. So as a sensible default, we give you an option to deploy to testnet, and you can potentially do some additional end-to-end tests and things like that. So let's go ahead into our smart contract project. So as I said, I was at the root right now, and this is our smart contract project. Another thing to highlight is the generate command. Every single smart contract template comes packaged with this notion of generators. If people are familiar with things like Ruby on Rails, if you look into this .algokit folder out of the box by default, you can see that there is a little folder called smart contracts in there. So what happens is it's a tiny Jinja template embedded into the instance of a template that you create when you do AlgoKit init. Using that particular generator allows you to essentially simplify and provide additional capabilities to your templates. And the cool thing about this is that it's completely extensible. So anyone who wants their own AlgoKit template to be created, they can essentially use our templates as a starting point, and they can also embed shareable components that we call generators. And in this case, we could say AlgoKit smart contract, AlgoKit generate smart contract. We could give it a name, for example. And in this case, let's call this particular contract proof of attendance. So I had something ready-made before, so I'll just hide this for the time being. And let's call this proof of attendance. So we can now see that it created the folder for us. By default, it's just a basic, hello world arc4 contract that you get. And so now let's do some changes to actually implement our proof of attendance contract. I would say we would want to have a very simple interface to essentially do a few actions, such as we have attenders, right? I would say, based on number of people here, I would say something like 20-30 people. So we would confirm the attendance, and I'm just outlining the skeleton, right? We would need a method to potentially get the ID of the proof of attendance, which is going to be an ASA minted for every person who confirms the attendance. And we are going to get the command to basically claim that particular ASA. So it's going to be two steps, right? You will confirm the attendance, your information will be stored in a box, and then in the next call, you can get this NFT transferred to your individual wallet. And since we are using Puya, there's a lot of additional simplifications, obviously, that it gives us simply by the fact that it is essentially a subset of Python. So we could use a regular, Python generator in this particular case, and let's create some global state variables, right? So we want to limit the number of attenders. So let's say we'll set it to something like 30 people. We would want to set a number of total attendees in this particular case, just to basically keep a track of people who are currently being who are currently confirming our attendance in this particular case. So I'm going to use AlgoPy namespace. This is just my personal preference that when I'm interacting with packages or namespaces from different packages, I like to access them through a specific namespace. In this case, having everything prefixed AlgoPy makes it very simple to distinguish where this particular information is coming from and distinguish the types as well. We can also save our asset URL in this particular instance. We have a ready-made asset created for those POAs. So I'm just gonna copy a quick link from a ready-made version of this contract. So we have the asset URL in place. And now let's start with the confirm attendance. It's going to be a basic Arc4 ABI method that is going to use boxes to store the information about the people who literally just signed up and confirmed the attendance to claim this proof of attendance ASA. As a first thing, obviously, we would need to check whether our total number of attendees does not exceed the max number, which we set to 30, as we can see here. And we would also need a few subroutines in this case. And the subroutines is obviously something that you can use to offload the computation into individual private methods. So Puya allows us to think about some of the abstractions available in AVM as native Python abstractions. So in order to create a private method, in this case, let's call this mint POA. This is going to create a subroutine for us, and all you have to do is obviously add a decorator that is going to tell Puya compiler that this is a subroutine. For the sake of time, I will copy the subroutines themselves, basically. So we'll take the mint POA and we'll take the send POA, and these are very simple subroutines that are essentially minting the ASA for the user, issuing an asset configuration in a transaction, as you can see here, and the other one is going to send this asset from the account to the person who is claiming it. And by account, in this case, I'm referring to account associated with an application that's going to be deployed with this contract. We can also add a few additional checks in this particular case into our confirm attendance method. So now we have the asset being minted that we can obtain through the mint POA subroutine, and let's access our current sender. So we're going to mint proof of attendance ASA for the person who is currently sending this particular transaction against the application. We can increment the number of total attendees, which we already did. And so once we get the minted asset, we potentially would want to store the information about this ASA and associate the user's wallet address with the ASA ID. So you can then also do lookups, whether you have an address of an account, what's the ASA ID for this account. So I'll use the box primitive. There's a higher level support for boxes. For the sake of this example, I feel like these could simplify interactions with it a little bit. I also was preparing this talk prior to the release of the higher level support for the boxes. This was done by colleagues of mine in parallel. So I'm using a slightly simpler version of boxes. But once again, there's a higher level interface available for that. And obviously, before we mint the asset, it would be strange if you can have infinite amount of abilities to mint this asset. We also need to check if the asset was already claimed and it was already minted by you. So when you interact with the lower level op box primitive, it always returns you a tuple, and the second value in this tuple is the boolean that tells you whether this box exists or not. And in this case, we can attribute this to whether this has been claimed or not. So I'm going to say we need to assert that it has not been claimed before, otherwise you're going to get an error. And then lastly, we are going to implement a few additional methods. Basically, I'm going to showcase a cool thing about abilities to simulate the transactions. So if we have an ABI method and we call it read-only, there are ways for you to access the results of that method without actually having to submit a transaction. And in this case, we can use this to quickly get a lookup and get the information on whether a particular wallet address already has a proof of attendance ASA, and if it does, we just need to get the ID of that ASA, right? So POA, I would say POA not found in this case, and we can return our ID. So notice that we are returning a uint64, which is a base primitive in AVM. I'm going to say whether the ID, let's call this POA ID. If this exists, that value is going to be returned. But one last thing is that when you access the box primitive through the base primitive, basically it always going to return you bytes. So the last thing you just need to do is confirm this, convert this into integer from bytes. So we get the response as an int, and then lastly, that's the call that you're going to make to essentially get this NFT to your wallet if you want to, right? So the confirmation of attendance marks you as attendee, and then it's like a vanity claim where you would want to get the POA on your wallet, basically. And once again, let me just implement this one real quick. It's not going to return anything. It will do additional set of validations. Actually, do have the implementation here, and I will just quickly cover what we are checking. So we are getting the ID of that. Let's also require the user to get the opt-in transaction in place. So it's going to be an asset transfer, and opt-in transactions, as some experienced developers here might know, is a simple asset transfer transaction that needs to send a 0 asset amount to itself. So we are just checking some additional parameters here.
Is the first assertion correct? Should we not exist? Or?
So this was actually hard-coded in the example as a as an intentional bug to showcase, but you were fast enough to note it. So but that's fine. There's a few others that we can play. Nice. But yeah, basically we're going to check. We're going to check if the value exists in the box. We're going to get the.
Original code, right? It needs to exist.
It needs to exist. Yes.
So the original code is right.
Okay.
Right. Yeah. So we are searching if it's true. It must exist. Otherwise, yeah. So it was correct. Yeah. The reason why I got confused is because initially the hard-coded thing was not, and the thing was vice versa. But anyway, so we get the fee covered for you because the contract on the mainnet that we'll use at the end already is pre-assembled. There is some additional balance on it, and we're just checking if the sender is our asset receiver. This is to confirm it's an opt-in, and then just basic security checks, right? It's usually a good practice. You need to check whether parameters like rekey, asset close to are all assigned to a global 0 address, because you must, unless this is some capability of your smart contract, by default it is one of the main security recommendations, because this is opening up a window to additional kinds of exploits, and people can do some malicious things with you. So it's really good to always confirm that it's assigned to a 0 address. If all of these are passing, you're going to do a send POA call, and that is essentially going to call our simple asset transfer in the transaction and send the ASA to the user's wallet. So
is the user opt-in, right?
User provides the opt-in as part of the call to the ABI.
Right,
So it's
opt-in so they can get the asset.
yes.
So you're checking a transaction that they created.
Yes, that they created, and then you issue an inner transaction call if the transaction for the opt-in that they
What
provided.
I'm saying is like your security checks, you're doing a security check on a transaction that you don't even care about or are involved in.
Well, in this particular case, it's more just to highlight on some of the importances around the rekey to an asset close to. But obviously, yeah.
The issue is that if someone created that transaction to do it themselves or that they tricked, basically.
Yeah. All right, so let's go ahead and also set up our project in this case. So I'm skipping some of the steps that you would get out of the box with the init, but bootstrap command is something that you would want to use as a first thing in order to get all of the dependencies from your project. So we'll do AlgoKit bootstrap all. In this case, I already have all the dependencies pre-installed, so we can skip that. The next thing that we can do in this case is essentially build our contracts. So we have a special command for that is already pre-configured for you through AlgoKit project run syntax. So if you do AlgoKit project run in this particular case, it should generate the project for you. I'm just gonna rename this to POA because it's a bit easier to deal with that way. So the build command, all it does is masks the execution to the Puya compiler, and the invocation of Puya compiler, I would just like to outline that is also available through the dedicated compile command. So if you go to AlgoKit compile, you can invoke Puya compiler directly, and there is some further improvements that we are going to be doing in regards to the native binaries. That would also eliminate the need for you to have Python pre-installed in order to use the AlgoKit CLI. But we just called the build command, and you can see that the artifacts folder is pre-populated with a typed client, and we get all of the teal artifacts for us. Just a quick showcase of the fact that IntelliSense is here and we have Algorand Python stubs covering us. It makes it really hard to have statically typed bugs or errors, even though I try to make them intentionally hard-coded in there. But just to showcase a quick example, so if you were to return bytes from a method that is supposed to return integer, right? Obviously, if you were to do build again, the Puya compiler should be pretty descriptive in telling you the exact line where the problem is happening. And so you can see that scenarios that require static type checking can quickly showcase you that, okay, you actually have a typo here, and then we can go ahead and investigate where the problem happened. And obviously, in this case, we're returning an invalid type. I'm just going to rebuild this real quick, and we can move towards showcasing some of the commands with the deploy. So the deploy command is, if you look into the project command group, and as an additional note, I would really recommend, whenever you have a problem with any of the AlgoKit commands, we have a very extensive documentation available on the repository. There's a lot of work going on with the revamp of the dev portal. But generally speaking, if you go to the AlgoKit CLI repo, under the documentation, we have a very detailed structure that is outlining every single command available in every single command group of the CLI. In this case, the project command group is everything encapsulating interactions with AlgoKit projects. And when I say AlgoKit projects, it's basically a template that you instantiate when you use the init command, and that project is defined by existence of the toml file called AlgoKit toml in this case. So we already did bootstrap. You can see some additional commands in regards to monorepos and run that we covered initially. But deploy is a separate command that is essentially allowing you to deploy your particular smart contract project into a network of your choice. You can see that you get different environment variable files available out of the box for you. And so let's actually make the deployment to localnet initially. In order to instantiate localnet, you would go ahead and do AlgoKit localnet start. I already had an instance running, so I'm going to do reset in this particular case. And also just to highlight, we recently released the support for code spaces. So for people who have hardware requirement or hardware limitations or unable to run Docker, you now can use Docker locally using the special AlgoKit localnet code space command, as you can see here. All you need for that is GitHub account, but you don't really need Docker at this point. And also another thing, just to quickly highlight, we also support multiple container engines at this point now. So if you're not satisfied with Docker, you can also use Podman, for example. Obviously, you could alias it to the Docker alias so that it uses a different container engine, but we now have native support for intercepting and interacting with Podman. So we just did localnet, restart, and let's do a quick deploy. And the logic that is happening here is, by default, if you don't say a particular network name when you're deploying, it's going to defer to the .env file. This is a generic deploy, and then you have env files prefix after the network name in this particular case. So if you say AlgoKit project deploy localnet, it's going to deploy it exactly to localnet. Let's do AlgoKit explore real quick. and it's going to open LoRa for us, and LoRa the Explorer. And here is the application that was recently deployed, but once again, we're still looking at LocalNet. I'm just going to showcase this is the NFT ASA that you're going to get once you get the POA in place. So we just did it to LocalNet. Okay, this is fine. What about some of the contents that we could get out of the box in terms of testing the contract before we actually go to mainnet, right? So now with the addition of the new feature that allows you to basically do runtime checks against Puya code directly in Python, there's two types of tests that you get now out of the box. So integration tests, POA client tests, something that you've already had out of the box in the existing template for a while, which is requirement for you to deploy it to LocalNet and then essentially have the contract checked against the real instance. But then you also have the unit tests now in place, and you can see some examples here that does not require interactions with a real Algorand network. This is for more smaller scope projects. So you would already get this out of the box in the templates, and it just gives an extra level of robustness and security when verifying your tests, because you can now iterate a lot faster and access directly individual chunks of logic within your smart contracts that does not require a lot of redundancy in setting up the network prior to you being able to interact with that particular contract. And so since we cannot have the confirm of the attendance happening twice for the single account, I do expect the second call to actually have some problems, right? So we just did the deploy to the contract, but what happens if we deploy it again? And for that, I would actually add an extra check here. So basically, this is essentially to confirm that you indeed cannot have the second call happen. So, okay, so we have the confirm attendance method. This is the integration test, right? So the first confirm just happened, it passed through, and this is sending a real call to the network. We can look it up in the LoRa Explorer once again. We should see some transaction activity in place on the historical transactions. So this, just give me a second with this one. Yeah, so you can see that this is an AVM runtime error, right? We just had a single static account trying to confirm it twice. The second confirm that is happening, you can see the interaction with the type client that AlgoKit generates for you just failed. What would you do in this particular scenario? All you have to do in this particular case is use the config that you get from AlgoKit utils, and that allows you to interact with our plugin that wonderful guys at Inc. and guys at MakerX were working on, which is called AlgoKit AVM Debugger. That allows you to essentially have line-by-line debugging of TIL. This is for more advanced scenarios where the problem could be really obscure or you really have access to only simulated trace logs. So if we say debug true, it's going to help us assemble all of the information needed to perform a proper debug in this particular case. So obviously it is not something that you can expect from testing code in general purpose language, right? In this case, you need to get trace information about what went wrong when you were trying to interact with the node. And so you need certain additional set of artifacts assembled for you. And this is where AlgoKit utils, in this particular case, helps you get those artifacts. So you can see that when we set true on the debug in the config method, it got the debug traces for us automatically. And then inside the .algokit folder, you will see that there is a get-ignored file called sources, and that gets the precompiled sources for a particular smart contract for us. All you have to do after that, and notice the amount of launch configurations available for you out of the box, so you can essentially have a first-class support for VS Code. The same set of launch configurations are available for JetBrains IDEs as well. So if we click debug TIL, you can pick the very last call that happened, which was the application call against the confirm attendance method. And firstly, it will basically just go through the transaction groups. It was a single application call in this particular case. And we can see the app ID that was against LocalNet in our case. And this is exact line that makes the assertions for us, right? And we cannot have a user claim it twice. So this is the basic assert. But at the same time, I would just like to showcase that you can also go back and forth in the teal stack. You have access to the scratch slots. You have access to stack itself. And there's different on-chain information as well. So this is really a huge improvement over the initial iteration of what was available with steel debugging. And with that in place, we basically have deployed our application. We saw some options around using AlgoKit compile to quickly identify statically typed errors. In this case, we were able to deploy it to localnet and also perform a assembly of artifacts required to also do debugging directly in teal. So for scenarios that require you to actually inspect your code after you got a runtime error. And you also saw an array of different capabilities available within AlgoKit CLI itself. So lastly, I would just like to outline a few additional things with the task, and after that we can go to the URL that you can scan and basically get this NFT. And once again, I'll open LoRa for that. But just to outline, the AlgoKit task command is a little collection of different applications, right? So if we were to deploy this, to testnet, for example, and I needed a quick address to be generated, I can use the vanity address command to get a quick wallet address. And say you want to have a testnet account that you want to play with. Please keep in mind that there's also an integration with AlgoKit dispenser, which is a really robust infrastructure that we have with a reputation system. So you can actually fund your accounts, you can get refund, you can return the algos back to the dispenser and get additional progressive rewards for that. So people who return testnet algos actually get rewarded, and they can fund and get a higher limit next time. So for example, AlgoKit dispenser fund, AlgoKit dispenser limit in this case showcases a limit for my account, assuming I'm logged in, right? Once you log in to that, it will essentially allow you to see your current limit. But the goal was, once again, to highlight the fact that CLI is the sort of entry point to this umbrella term, and there's different kinds of libraries, frameworks, tools, and external systems integrated into the CLI that allows you to efficiently use and debug your AlgoKit smart contracts. And so with that, I would like you to scan this particular QR code. This is going to open the application that was written with another starter template. We just didn't have enough time for covering this within 30-minute window. So it's something that you can actually get using the AlgoKit init React template. So this is our default React template, and it's modified to basically issue two calls that you just saw. So this is the
Turn on that switch off. Turn it off. Yeah.
This one?
Yeah. No,
Is it cool or both?
Both. Yeah.
Yeah. Cool.
I thought about running around there and
Yep. If someone has issues with scanning it, let me know. I will basically just display a URL.
Ow. This transaction fee's higher than usual. I got a warning.
So
It's 0.002.
yeah, it's 0.0. You would need a tiny little bit of algo on your wallet on mainnet in order to do it. And let me open up LoRa now. So this is our application ID. This is the live transaction activity. As I said, there's two kinds of transactions. And the first three wallets, to do it, I would just reach out to you later on, and you will be able to fill the form and claim the Subtopia instance after it. Yep, we see the first person already claimed. I don't know who that is. We see the second one. Let's see. Let me just zoom this in. And once again, by the way, LoRa, I know we covered this already, but LoRa is completely in browser. It doesn't require any backend in this case. This is using the TS subscriber library, and the blocks here are actually coming real time. But once again, it's a completely open source blockchain explorer. You can fork this if you want. Contributions are very welcome. But the point is that now in Algorand ecosystem, we have a solid backbone for an explorer that provides a lot of capabilities out of the box and fully open sources the code base in potential contrast with scenarios where you would want to monetize particular features. But yeah, it's a fully open source. Explore. If you're interested in the code base, please check out the code. But yeah, we already have more than 3 people, I believe, at this case. So yeah, I think with that, I'll reach out to people who claimed it. The first 3 winners, you will get a little transaction note with a URL. Just open up that form later on, and you will be able to provide all the information you need to claim it. Yeah, no. It's just that I will inform you because I don't know whose wallet it is. But yeah, with that, we covered a range of different features, and as a final recap, as I said, we outlined AlgoKit CLI, we did deploy, we did bootstrap, majority of the major interactions that you can do through the project command group, and you can see a live application deployed on mainnet that we coded during this session, and thank you very much for listening to me and participating.